Hello everyone, welcome to Unacademy. This is your Sathyamoorthy sir. Let's crack it. Today in this video we are going to discuss about the maxima and minima from its basics. After discussing the concepts of the maxima and minima, we are going to start the previous questions. Few previous questions from mechanical engineering, electrical engineering, electronics, as well as from the computer science and as well as civil. Maxima and minima. Before moving to the concepts, I will tell you the Unacademy compact details as well as forthcoming batch course details for you, so you can get benefit through the compact. Unacademy is the largest platform, and in that they are conducting the India's largest weekly competition for GATE. Assess your GATE preparation in 60 minutes, challenging and original GATE questions curated by the best educators in the Unacademy platform. Take it live to compete with best, super fast and fun with the All India live leaderboard. Identify, improve your weak areas through the detailed video solution. After completing the Unacademy compact test, for the same questions you will get the detailed video solutions by the best educators in the Unacademy platform. So next 20, it's over. Here it's 13, it's over. 6, it's over. Next 27th, next Sunday, coming Sunday 11 a.m. the last compact in the June month. You can participate into the June month compact, then you can get some benefit through the Unacademy compact. So the eligible departments are mechanical engineering, civil engineering, electrical engineering, electronics and communication, computer science and information technology. So these departments eligible. Use the referral code Moorthy 536. Use the referral code Moorthy 536 to get maximum discount in the Unacademy platform. And through the Unacademy compact, so these are the benefits you can avail. And if you secure the rank 1 to 3 in the Unacademy compact, complimentary Unacademy Plus subscription for 1 year will be provided to you. And if you secure the rank from 4th to 10th, 75% offer on the Unacademy Plus subscription, the tensor of your choice. The rank 11 to 50, 50% of the on Unacademy Plus subscription for your choice, and 51 to 100 place. If you secure the 51 to 100 place, then you can get a 25% offer on the Unacademy Plus subscription for the tensor of your choice. The winners can choose from 6 months, 12 months, 18 months or 24 months GATE ESE Plus subscription. Okay, so these are all the benefits you are getting through the Unacademy compact. So register now itself, and for the next compact 27th June at 11 a.m. use the code Moorthy 536 and to attend the test. The price hike will be there. So already in the previous videos itself I have discussed about the price hike. The price hike is coming soon for the GATE and ESE category, and if you want to beat the price hike and take the subscription now itself, this is the right time to take the subscription and start your preparation for the GATE 2022 as well as for the GATE 2023, and use the referral code Moorthy 536 to get the maximum benefits in the platform. 10% offer you can get, and if you use this referral code you can get 10% offer on your plus subscription. And the batches, already the June 16th we have started the batch, and Spark for GATE 2022 and Wave for GATE 2023. Mechanical English batch only, completely batch B. And Praveen Kulkarni sir, Devendra Singh Nehi, Vivekanand sir and myself, we four together handle the complete course for the mechanical engineering. Use the referral code Moorthy 536 to enroll into the batch courses. And then one more batch, okay, Lakshya plus Arohan and GATE 2022, and for the GATE and ESE 2023 mechanical engineering, it's complete course, and we are starting with the theory of machines by Akash Tyagi, and 23rd June and 10:45 a.m. use the referral code Moorthy 536 again to enroll into this course also. Some highlights from the GATE 2021 results. So these are all the top 100 rankers. Below the 100 ranks, the Unacademy students, they have secured the AR 12 AR 14, AR 24, AR 26 and AR 29 by preparing through the Unacademy Plus. And it's a products and engineering all India rank students. AR rank 3, 10, 15, 27 likewise up to the 77. It's below 100 and below thousands of learners are there from the Unacademy. Here I am highlighting the below 100 AR rankers secured the production department, and as well as for the engineering science EXE paper. So these are the all India ranks secured by the Unacademy learners, and it's from the civil engineering. It's a civil engineering, and here it's a GATE 2021 rankers chemical engineering. Congratulations for the students. Balupaki AR 2 to the AR 57 they have secured. And it's computer science and IT, all India rank 12, all India rank 20, 26, 53 likewise up to the 95. So these are the members have secured the all India ranks below 100. And in computer science and IT part in the GATE 2021, as well as for the electrical engineering and it's electronics. And look at this research. Siddharth Sabharwal, educator as well as an academic learner, he has secured the all India rank 1 in the GATE 2021 EC category, electronics and communication in paper, right? So these are the students have secured the top 100 ranks, okay, below the 100 ranks in the EC. It's an instrumentation. So you also one among them in the GATE 2022 and 2023. And so this is the right time to take the subscription and start your preparation for the GATE. And wonderful educators are there in the platform. Definitely we are going to help you to succeed into the GATE 2022 as well as 2023. Take the subscription and start prepare your content now itself. Now we are moving into the GATE Engineering Mathematics from the calculus chapter Maxima and Minima. Maxima and Minima. From the given function, we are going to identify the maximum value, where the maximum value lies, where the minimum value lies, and what will be the maximum value and what will be the minimum value. So these are the things now I am going to explain you from its basis. So you can get some idea about the maxima and minima. So what is maxima and minima? In case they are giving, so maxima and minima. So these are the procedures to identify the maxima and minima for the single variable. Single variable means in case function contains only one variable x or it may be a y, then the function is called a single variable function. Now I am going to give you the function. Now take some function. Let f of x be the function, single variable function. Single variable function. Now, so what is the maxima and minima? First, I am going to give you the clarification on what is maxima and what is minima. Now, in case we are going to draw the lines, okay, graph. Here, yes. Okay, with respect to some point. Here I am going to give you, right? Look at this image. It's a function. So this is the f of x. It's a graph for the f of x, and path followed by the function f of x. In case you are taking in case they are giving the equation, it may be an equal graph or unequal graph. It may be anything. It may be anything, right? Here, in case they are asking what is where we are getting maxima and minima. There are two kinds of maxima and minima: absolute and as well as absolute maxima and minima, and it's extreme points. Extreme points are maxima and minima. What is meant by absolute maxima minima and normal maxima minima? I will tell you. Now consider. So these upper peak points are maximum points. These upper peak points are here. These are the maximum points. So these are the maxima. So among all the maximum points, the lower peak points are called as minima. So I will give you the different colors so you may get some clarification, right? Now, so these are all the, now consider the lower peak points are minima. The lower peak points are minima. Here, this maximum peak point, the maximum peak point is called as absolute maxima. Absolute maxima. The lowest peak point, lowermost point, peak point is called as absolute minima. Absolute minima. So this is the point we are going to get. So this is the point we are going to get. There are two kinds of functions are there. One, in the given function they may ask where the maxima and minima lies. Point at which, in case if you are giving the value x value, if you take the x is equal to 0, 1, 2, 3, 4, 5, 6, 7, okay, it's 8, 9, 10. Here there are two different things are there. There are two different things are there. I will explain one by one, so you may get it. Here, in case they are asking maximum point and minimum point. In the function, there are many maximum points are there. Absolute. So the absolute maximum only considered as maxima. Okay. Now, absolute minima is considered as minima. But we are getting many maxima and minima points, right? In case they are asking point at which we are getting maximum point. Point, in case if you take its y-axis, this is x-axis, at point 7, at x is equal to 7, we are getting the maximum. We are getting the maxima, right? Here, at point 10, at x is equal to 10, we are getting minima. We are getting the minima. Is it clear? Point at 7, x is equal to 7, we are getting maxima. So there are two kinds of questions are there. One is they may ask first value of maxima and minima. It's one category. Type 2, they will ask point at which we are getting the maxima. Point at which maxima and minima lies. So there are two types are there. So these are the two types we are getting the questions from the competitive exams. Is it clear? Yes, in case you are having any doubt, so kindly ping your doubt immediately so I can give you the instant reply for your questions, queries. So this is the basics of the maxima and minima. Then how we are going to identify the first type 1 we are going to identify. Type 1 we are going to identify. How to identify the maximum or minimum value, first category. Next one I am going to explain you with the second derivative. Maximum and minimum values are identified by using the first derivative method. The point at which maxima or minima lies, the second type is derived with the second derivative method. Now we are moving to the first type. We are going to identify the maxima and minima values of a function. Single variable function. So how to identify the maxima and minima of a single variable function. So coming to this question, first method for finding the extrema. Extrema means it's maxima or minima. Let y is equal to f of x be given. In case if y is equal to f of x is the given function, step 1, there are 3 steps are there. Okay, these 4 steps, while solving the problem we are converting into the 3 steps. I will explain you. So how to do it, right? Now find f dash of x. Step 1, find f dash of x. The first derivative of the function is identified. Step 2, find the critical numbers of f. This is obtained by solving f dash of x is equal to 0. What we are doing, the first one, the first derivative is equated to 0. By equating the first derivative, we are going to identify the critical numbers. For example, I am going to give you, in case it's x cube plus 2x square. Okay, so whenever the value, take it as minus. Now x square, so this is the function. Now first step 1, what we are doing, first derivative f dash of x, it's a 3x square minus 4x, 2 into 2 4x. It's the first step. Step 2, it's step 1, here it's steps 2. The first derivative is equated to 0. While equating the first derivative is equal to 0, 3x square minus 4x is equal to 0. Right? Now you take the value, take the x outside, then what we will get, x into 3x minus 4 is equal to 0. Now x is equal to 0 and x is equal to 4 divided by 3. So these are the two critical numbers. These numbers are called as critical numbers. Critical numbers. It's a step 2. Then step 3, in case they are giving the function, in case they are giving the limit, I am giving you, right, minus 1 comma 3. In case this is the given limit to identify the maxima and minima in this interval, minus 1 to plus 3. From the minus 1 to plus 3, where the maxima or minima lies, in between these two limits we have to draw the graph for the function or all the points. Then we need to identify the maxima and minima. And second step, we are identifying the critical numbers. Step 3, now end points of the domain f, let a and b are the end points, so we need to take the end points from the given limit. So it's point a, minus 1 is a, 3 is b, so these are the end points. Step 4, the final step, find the values of y is equal to f of x at each critical number and at x is equal to a and x is equal to b. X is equal to a and x is equal to b. Select from these values of y the largest y value if an absolute maxima is decided. In case if you want maximum value, after substituting each point, we need to substitute the critical number x is equal to 0 in the f of x function, s plus 4 divided by 3 into the f of x function, and minus 1 and 3. All the values are substituted into the given function. Then maximum largest value among all these values considered as maxima, and smallest value among all these 4 values is considered as minima. The one more thing we need to keep in mind, my dear students, okay, please make a note of it. And here, after identifying the critical numbers, we need to check whether the given points are lies inside the given limit or outside the limit. Minus 1 to 3, so 0 lies inside the given limit. 4 divided by a is equal to, it's 1.33, so this value also lies inside the given limit, so we can take. In case the point lies outside the limit, in case point lie instead of minus 1, in case if they are giving plus 1, what will happen? So it's x is equal to 0 lies outside, x is equal to 0 outside. Okay, this value, yes, lies outside. This value lies outside. So we are not considering the x is we are not substituting x is equal to 0 in the function. The value x is equal to 0, it will not be considered to identify the maxima or minima. That means to identify the extrema, the x is equal to 0 should not be taken into the account, because the value lies outside the given limit. The points, which are all the points lies inside the given limit, these points only consider for the extreme of identification, right? One example I am going to give you now. After that, I will show you some previous year questions. Then I will give you the solutions for the previous year questions also. Then you will get some idea about the maxima and minima. Now, find the absolute extrema in this question. Find the absolute extrema of the function f of x is equal to x square minus 4x minus 5. So this is the given function. Minus 1 less than or equal to s less than or equal to 3. Here minus 1 s plus 3, both included into the given limits. The extreme points are also considered. In case instead of less than or equal to, in case they are giving only less than, we should not consider the minus 1. Less than or equal to, so we are considering this value. Step 1. First step, what we need to do, we need to identify the first derivative of the function. Now differentiate the given f of x function one time with respect to x. Now f dash of x is equal to 2x minus 4. It's the first condition. Second step, what we have discussed in the step 2, find the critical numbers by equating the first derivative is equal to 0. So we need to equate the first derivative is equal to 0 to identify the critical number. While equating the first derivative is equal to 0, 2x minus 4 is equal to 0. Therefore x is equal to 0. So we are considering it as x1. In case we are getting two numbers, x1, x1, x2, x3. So in this order we are getting only one number, so we are considering it as x1. Then we need to check whether this point 2 lies inside the given limit or outside the given limit. x1 is equal to 2 lies inside the given limit. If you consider the limit minus 1 to plus 3, it lies inside the given limit. So what we need to do? So we need to count this number to identify the critical extrema, maxima or minimum value. Now substitute the value critical numbers as well as end points. Here end points are a is equal to minus 1, b is equal to b. Now I am substituting the end points as well as critical number into the function in step 3. F of a. F of a is equal to minus 1, f of minus 1. Instead of x we are going to substitute minus 1. Minus 1 the whole square. Minus 4 into minus 1 it's plus 4. Minus 5. It's equal to 0. Second one. F of b. F of b is equal to f of 3. 9 minus 12. 3 square is equal to 9. Minus 4 into 3 is equal to minus 12. Minus 5. It's equal to minus 8. Next one. We need to substitute the critical number also. F of x1. F of 2 is equal to 2 square 4. Now it's 4 into 2 is equal to 8. Minus 8 minus 5. And if you simplify the equation, minus 9. So here the maximum value as well as minimum value. So this is the value we need to identify. So these are the values we need to identify. The largest value of y from f of a, f of b and f of x1 is called absolute maximum. Is called the absolute maximum. And now the largest value among the 0, minus 8, minus 9. Largest value it's 0. 0 is the largest value. By comparing with the negative numbers, the positive number or 0 will be the maximum one. So 0 is the maximum number. So the maximum value for this function is y is equal to 0. Then smallest value of y from the f of a, f of b, f of x1 is called the absolute minima. While comparing these three numbers, minus 9 is the smallest number. So the minimum value of the function is equal to minus 9. I hope it's clear for all the students, right? And so this is the first method. There are two methods. There are two types are there. First type, identifying the value of maxima and minima, identifying the maximum and minimum value. Today we are going to discuss the type 1. Tomorrow in the second session, next video, we are going to discuss second type. In the second type, point at which the maxima or minima lies. So this is what we are going to identify in the next session. I will explain this type 2 in the next video. Today, now the type 1, it's a best example for the type 1. To find the absolute extrema of the point of the function, f of x is equal to x square minus 4x minus 5. Now I am going to give you one example problem to you, so you may get some idea about the maxima and minima. The first question I am going to give you, listen. Okay. Minimum value of the function. Minimum value of the function. Here I will tell you what mistakes students usually they are doing in these kind of questions. It's a mechanical engineering 2007 1 mark question. 2007 it's a 1 mark question. Minimum value of the function. And while identifying the minimum value, first what we need to do, step 1. Step 1, first derivative of the function. Step 1, first derivative of the function, f dash of x. F dash of x. F dash of x we need to identify. The f dash of x is equal to, that means now take it as y is equal to f of x. The function depends upon the variable x. Now f dash of x is equal to x square is equal to 2x. Step 2, we need to identify the critical numbers. Then how we are going to identify the critical numbers? The first derivative is equated to 0, and while equating this value is equal to 0, 2x is equal to 0, therefore x is equal to 0. So we can take it as x1. x1 is equal to 0, right? Here you may did the mistake while substituting the a and b end points. Step 3, end points. Here end points are A is equal to 1, b is equal to 5. You may think that minimum value is 0 while substituting x is equal to 0, so we are getting 0. It's not like that. Why? Because we need to check, after identifying the critical number, we need to check whether the critical number lies inside the given limit or outside the limit. Here lies outside the given limit. Okay, outside the given limit. So what will be the given limit? Given limit is it's 1, 5, and if you consider the 1, 5, it's outside the limit, right? So we are not going to consider this x is equal to 0 to identify the extrema. Only the end points are identified. In case we are not getting critical numbers inside the limit, then we need to identify the maxima and minima by using only the end points. Now the end points are, first end point f of a. F of a is equal to, it's f of 1, it's equal to 1 square is equal to 1. Second one, f of b, it's equal to f of 5. 5 square is equal to 25. Now the minimum value they are asking, while comparing the 1 as well as 21, minimum value is equal to 1, right? So we should not select it's equal to 0. We should not select it's equal to 0. And one more question I am going to give you. Listen. It's a mechanical engineering 2016 set 1 2-mark question. Maxima and minima. Consider the function f of x is equal to 2x cube minus 3x square in the domain. They are giving the domain minus 1, 2. The global minimum of the function f of x is step 1. So what we need to do in the step 1? First derivative of the function f dash of x is equal to, it's 6x square minus 6x. 6x square minus 6x. Step 2, we need to identify the critical numbers. In step 2, the first derivative is equated to 0 to identify the critical numbers. Now the 6x square minus 6x is equal to 0. Now take the 6x outside. So we can take 6x outside. Now x minus 1 is equal to 0. And if you take the value, x1 is equal to 0, x2 is equal to 1. So these are the two critical numbers. Now we need to identify, we need to check whether the points are lies inside the given limit or outside. X is equal to 0 as well as x is equal to 1. These both values lies inside the given limit because the given limit is minus 1, 2. Now the step 3, what we need to do in the step 3? We need to substitute all the values. Step 3, first one, it's f of the given limits, f of a, it's f of minus 1. Now substitute minus 1. If you substitute minus 1 power 3, it's 3 into minus 1 the whole square. It's equal to, what will be the value here? It's minus 2 minus 3. It's equal to minus 5. Second one, it's f of b. F of b is equal to f of 2. Here it's minus 1, here it's 2. 2 into 2 cube minus 3 into 2 square. It's equal to 16 minus 12. 16 minus 12 is equal to, it's 4. Is it clear? 2 cube is equal to 8 into 2, 16. 16 minus 3 into 4, it's 12. 16 minus 12 is equal to 4. Next one, f of 0. We need to substitute 0. F of x1. The f of x1 is equal to f of 0. It's equal to 0 minus 0. It's equal to 0. Next one, f of x2, the value f of x2 we need to substitute. F of x2 is equal to 1, it's equal to 2 minus 3, it's equal to minus 1. Now consider all these values. So what will be the smallest value among all these points? If you consider these 4 values, minus 1, 0, 4, minus 5. Here minus 5 is the maximum value. Minus 5 is the maximum value in this function. Global minimum, it's minus 5. So we need to substitute the values into the function, then we need to identify the global minimum. It's minus 5 is the right answer. Okay, is it clear now? Okay, thank you students. Now we are going to close the session. In the next video, in part 2, calculus maxima and minima part 2, the type 2 problem, the point at which we are getting the maxima and minima, it will be discussed from its basic. So stay tuned to the Unacademy YouTube channel to get the next session, and try to subscribe to the Unacademy Plus platform. There you can get the complete course. So I am handling the complete engineering mathematics for all the departments, common to all the departments. There you will get all the concepts from its basics along with all the previous questions. Okay, thank you.